Hi guys, it's been a long time, and due to the COVID pandemic situation, it takes time. So I have to adjust with the time, with the work schedules, etc. I hope that you understand. Today I will discuss about lighting load calculation for an indoor area or space. This is very important because if you have a certain area or occupancy, for example, a room or a part of any building, for example, dining room, living room, etc., there is a particular calculation for that. So I will discuss two uh, types of calculation. So please stay and watch until the end, so you will understand and you can decide what type of calculation that you are going to do, which one is applicable. Okay, moving on. This is still part of the electrical fundamentals that I am discussing, which includes design, installation, and maintenance. For now, we are still on the design stage. So later, as we move on, slowly but surely, we can discuss many topics and matters regarding electrical engineering, electrical installation, electrical wiring, and whatever electrical matters that you are interested of. What is a lighting load? As a description or meaning, a lighting load is the amount of lighting or illumination level in terms of lux. This is the unit of measure required in a particular place or occupancy to provide a safe and comfortable lighting system for the intended activity and occupants. This lighting load must be converted into watts or volt amperes for the circuit design calculations. Here I will show recommended levels of illumination by the lead, which is allowed lighting power density. So according to the table, there is a column interior location and task. It means the area and what tasks are being done or intended to do. Then the illumination level. This is the in terms of lux, and the equivalent uh, lighting power density in terms of watt per square feet or watt per square foot and watts per square meter. So here, homes where in our houses, for example, and residential buildings, in general lighting, illumination level is recommended to have 200 lux, especially also in the dining room. So 200 lux is recommended. Just take note. And in terms of power density, lighting power density, it is 1.1 and 2.1 watt per square feet respectively, and 11.8 and 22.6 watts per square meter respectively. So take note of this. So that means in any building or in any occupancy and in a particular area where there is a specific task to be done, or the area is intended for that task, there is always an illumination level. This is for the safety, for the convenience of the occupants or the people who will be using the area. It is not like just you are putting any lighting or whatever it is. We don't know the illumination level. This is not correct. That's why in lighting engineering, there is always a recommended illumination level. Now, this is actually an excerpt from a book, Manual for Lead Compliant Lighting Design, that is in Table 5.1. Selected locations and tasked with corresponding IAS recommended illumination levels and lead allowed lighting power densities in watts per square feet and watts per square meter. Another table which I am going to show is the general lighting loads by occupancy. This is from the National Electrical Code, Table 220.12. Here, for the dwelling units, or shall we say residential buildings, here it is recommended unit load volt amperes per square meter. So it is recommending 33 volt amperes per square meter and 3 volt amperes per square foot. So take note of this also. We will see how we are going to use these tables. So as I said, this is NEC table 220.12 lighting load for specified occupancies. A unit load of not less than specified in table 220.12 for occupancies specified shall constitute the minimum lighting load. The floor area for each floor shall be calculated from the outside dimensions of the building, dwelling unit, or other area involved. For dwelling units, the calculated floor area shall not include open porches, garages, unused or unfinished spaces not adaptable for future use. So these are just some notes regarding this table. And as an informational note, the unit values are based on minimum load conditions and 100% power factor and may not provide sufficient capacity for the installation contemplated. So it is mentioned here, it may not provide sufficient capacity for the installation contemplated. So here the NEC already recognizes that this table may not be sufficient. Okay, so moving on. So now I will present to you the calculation methods. There are two methods generally used for calculating lighting loads. One is the area method. So this is approximate calculation using the allowed lighting power density. As I mentioned in the table used by IES and by other books and the NEC. And the number two is the lumen method. This is the accurate calculation using engineering formula and standard lighting table values. So first, let us discuss by area method. Example, let us have an example here. So we are given a floor area, example 152 square meter. It is quite a big area, equivalent to 1636.11 square feet, or but dimensions are 16 meter by 9.5 meter. This is part of a bungalow house, residential dwelling unit, and this area is actually a living room. So let us take note. We are going to calculate lighting for a living room in a residential area, residential or dwelling unit. So lighting load using the NEC, you remember that table. So 152 square meter, this is our area. we multiply it by the 33 VA per square meter as mentioned previously in my NEC table. So lighting load is equal to 5016 volt amperes or VA. Here, number of branch circuit can be calculated. However, the code provides demand factors for lighting loads. NEC table 220.42 provides lighting load demand factors. So let us see. So this is the table 220.42 lighting load demand factors. So it is mentioning for dwelling units, the first 3000 VA, you have to apply 100% demand factor. For the next 3000 to 120,000 VA, you have to use 35% demand factor. And the remainder, you have to use 100, remainder over 120,000, you have to use 25% demand factor. So this is the lighting load demand factor table, general lighting. The demand factors specified in table 220.42 shall apply to the portion of the total branch circuit load calculated for general illumination. They shall not be applied in determining the number of branch circuits for general illumination. So this is the notes about this table. So continuing by area method, lighting load as we have calculated is 5016 VA. For a 220 or 230 volts nominal utilization voltage, I for lighting load, so 5016 VA divided by 230 volts. So the current for the lighting load will be 21.81 amperes. This is the total current of our lighting circuit, the total lighting load. So number of 15 ampere circuit, we will use 15 ampere as a standard by the National Electrical Code or a Philippine Electrical Code. So number of 15 ampere circuit, so 21.81, let us divide by a 15 ampere circuit. So number of 15 ampere circuit will be 1.45. A circuit cannot be a fractional because it is a whole number. So we can say 1.45, we can say 2 circuits. Let us make it 2 circuits. So 2 circuits of 15 ampere lighting branch circuit to allow flexibility and future needs. So that's it. We have the 2 circuit. Note that as per the code, a 15 ampere branch circuit can only carry a maximum of 12 amperes. Remember that only 80% of the circuit capacity must be used. For example, a 15 ampere, 80% of 15 ampere is 12 ampere. So let us calculate the wattage. If we have 12 amperes maximum times 230, we have 2760 per circuit. So this is the wattage that we can apply in this 15 ampere circuit. 2760 watts only. At 100 watt per fixture, for example, we make it a 100 watt per fixture or per lighting set luminaire. So that will be 28 fixture. So 2760 divided by 100, it will be 27.6, or let us make it 28. So it will be even number. So we can plot in the drawing also, because we cannot plot an odd number the lighting fixture in the area. It will be odd. So let us always make it even numbers. Okay, 28 fixtures maximum. In this case, you can put more lamps, but you don't exactly know how many lamps would be enough to provide the proper illumination level of the area. So it is showing that you can put more lamps because it is 28 fixtures and you can assume only the wattage. But the illumination level, the lux required by the area, which is a living room, we don't actually know. We don't have a basis. So it could come as over illuminated or under illuminated. So this is the disadvantage of this area method. So continuing, given floor area 152 square meter, 1606.11 square feet. Now let us plot the room where we will put our lighting. So this is 16 meters by 9.5 meters and two circuits already determined. A number of fixtures determined with assumption that one fixture is 100 watt, but level of illumination is not clear. As I explained, will the illumination level be enough or exceed for the area and intended task? It is not clear. Okay, it is not clear. What is the illumination level? More wattage is more costly than a properly illuminated space with less wattage consumption. So here, this is the disadvantage of the by area method. Now let us go to the second type of calculation for the lighting load, and it is by lumen method. Lighting layout at assumed 100 watt fixture with a known illumination level 28 fixture. So this is the assumed one. So let us see. So this is still a by area method actually, and we just show that there are 28 fixtures, so no proper illumination level. This is the highlighted now. So moving on, illumination level is the amount of light in lux falling on a surface. It is the luminous flux lumens spread within the area in square meters of a designated space in the building. So see, there is actually a lighting level or lighting illumination level for any area, which is recommended by the lighting engineers. 1 lux is equals to 1 lumen per square meter. Lumen method of calculation is a method or zonal cavity method. This is the other name. Has been standard procedure in calculating the illumination level in interior task-oriented spaces. Take note, in interior task-oriented spaces for a general uniform lighting system. It is clear. Factors that influence illumination calculations. This is still by Lumen method. Number one is luminaires assembly. Of course, here you can select whatever luminaires or whatever lighting fixtures you want. Number two, mounting height of luminaires. Of course, it will affect the calculation, the height of the luminaires. And number three, ceiling cavity reflectance. This is value can be taken from the tables of the lighting manufacturers. Wall reflectance as well, it can be found in the table. Coefficient of utilization, CU. We can also found in the table total initial lamp lumens or lamp lumens. The lamp lumens that can be provided by the lamp or by the fixture. Light loss factor, or sometimes is called maintenance factor. This is the factor that is being applied because initially the total lamp lumens later will become less due to dust or whatever debris or dirt that will going to stick to the lamp. So we have to apply some maintenance factor or light loss factor. Coefficient of utilization CU can be taken from manufacturer's table, knowing the ceiling reflectance, wall reflectance, and room cavity ratio RCR. If RCR value falls in between table values, an interpolation can be employed. So if you cannot get the exact RCR, room cavity ratio, you can apply the interpolation method. So to find the values in between. This is being taught in college also. Or if you cannot understand this, then I might as well include in the video or just ask question below my video so I can give you the example of calculation. So now it is selected 2 by 20 watts. So last time in the area method he used 100 watt. Here he selected, we can select 2 by 20 watts. Land light LED, which is 2600 lumens total. 20 watts, one lamp, 1300 lumens each lamp. This is in page 31, Manual for Lead Compliant Lighting System, a book by IIE. This is the table. I selected land light LED, this one. So this is the model UPTL TL for 20 watts. The wattage is 20 watts and the lumens is 1300. So two numbers of this lamp, total of 2600, and the average life also is mentioned there, 40,000 hours. Now let us proceed to the calculation. So given the floor area 152 square meter, this same area we use for the area method, 1636.11 square feet, bungalow, residential dwelling unit, and the same living room. So other details required, mounting height is 2.5 meter. Here it is detailed now. We have the mounting height. So decide for the lighting fixture with its lamp lumens. So this is the one that I mentioned. So you can select what kind of lamp you want. It will come out later how many lamps it will be depending on the lumens, because there is a requirement. So here 2 by 20 watts land light LED, 2600 lumens total, 20 watts, 1300 lumens each lamp. Page 31, manual for lead compliant lighting system design, IIE book. So find from product catalog its coefficient of utilization. To find it, estimate the reflectance factor in ceiling and wall. Then calculate room index IR or room cavity ratio. So it is the same, room index or room cavity ratio. If RI or RCR falls in between table values, do the interpolation as I mentioned. Have an estimate also of the maintenance factor or LLF, lamp loss factor. Average value for maintenance factor or lamp loss factor is 70%. So you can always use 70%. This is the average value that you can use. It depends on you. If you think it is 80%, you can also apply, or maybe 60% you can apply. But this is the average value. Just for the sake of calculation, you can stick to 70%. This is recommended by many books in the lighting engineering. With all that, coefficient of utilization can directly be taken from the tables. Number of luminaires can now be calculated. So if you have the coefficient of utilization and all other values, we can now calculate for the number of luminaires. So now the calculation formula for the number of luminaires or fixtures. This is the formula. Number of fixtures is maintained illumination times area all over number of lamps times lamp lumens times coefficient of utilization times maintenance factor. So MI, this is the IAS recommendation. As you remember, this MI or maintained illumination, this is the initial lamp lumen given by, recommended by the lighting book IAS. So this is the meaning of initials. MI is the maintained illumination in lux as recommended by the book. The area is actually floor area to be illuminated. Number of lamps NL, lamp lumens for the LL, coefficient of utilization CU, and maintenance factor MF. Okay, so take note and memorize this formula. Now getting the room cavity ratio, or in other calculation that is room index. Here we are going to room cavity ratio. This is the formula. 5 times the quantity H minus H times 1/2 of B over A. So what are the meaning? RCR is the room cavity ratio. H is, big letter H is the mounting height of luminaires from floor. It is in meter. And the small h is the height of work plane, generally 0.7 meter. You can use it as standard, 0.7 meter. And P is the perimeter of the room to be lighted. Take note, the room to be lighted. And area is the room to be lighted. Area of the room to be lighted. And it is also in square meter. So take note, the units must match with the other variable units. So now using the formula, we apply the values as we have given before. 5 times 2.5 meter, this is the height of the big letter H, and the small letter H is 0.7 times 1/2 times the perimeter, which is 25.5 meter, and the area 152 square meter. So RCR is equal to 0.755. Now just for calculation's sake, we will make it a 1.0. So we will assume a 1.0 for easy use of table. Otherwise, we will use the interpolation. That is also possible. But to show you quickly, how to use the table. So this is it. So assuming ceiling reflectance factor 50%, I always use ceiling reflectance factor as 50% because when the luminaire is hanging, it will not reflect all from the ceiling. So I always assume 50%, and for the wall, I'm assuming a very less, 30%. So using that reference, you can get the coefficient of utilization, which is 0.73 from table 3.1, page 41. Let's see. So this is the coefficient of utilization table. This table you can also see in other lighting manufacturing books. So it depends on what lamp you are using. Just use their table as long as it is done by lighting manufacturers, because they are also following the standard for the IES. So let us see here. So I selected the 50% for the ceiling reflectance and 30% for the wall reflectance. So following the arrow down, and also we check the RCR. So we will use 1. So we'll get, so that will get easily the value, and following it horizontally and vertical line, so we will get 0.73. This is the value of CU, or coefficient of utilization. Now we will apply it to the number of fixtures, or the number of luminaires. So maintained illumination is 200 lux as given previously in the table, times 152 square meter area. Then number of lamp 2. There are 2 lamps which we selected, and the lamp lumens is 1300 each. And the utilization factor we already got from the table, 0.73, and the maintenance factor, as I mentioned, average value 0.7. So we get 22.88 number of fixtures, or say 23, but 23 is odd number, so we cannot plot very good in an area, rectangular area. So better we use 24 to make it even. Okay, so now we have 24 numbers, 2 by 20 watt, 1300 lumens each. So the total watts is 960 watts. So let us see later the difference. What are the advantages? So here we have only 24. Previously we have 28. And 2 by 20 watts. So this is only 40 watts. One fixture, 40 watts. Previously it was 100 watts. And previously we don't know the lumens, but here we know 1300 lumens. And this number of fixtures will give you the area maintained illumination of 200 lux, because it is applied in this formula. So we are sure that the task for this, which is a living room, it will exactly give, or better, 200 lux. But that one previously, maybe it is more than illuminated or less than illuminated. We don't know, because we just estimated it. But here it is calculated. And see, we have only 960 watts. Yet the lumens, or the illumination, is satisfied. So we'll make it 1, or two 15 ampere lighting circuits. So 24 numbers, it's up to us. But for me, I will make it 2 circuits so that there will be flexibility and reliability. Lighting layout calculated 24 numbers, 40 watts fixture with illumination level of 2600 lumens. So let us plot now the lighting fixtures in our room area. So the same 16 meters by 9.5 meters, and see here 1 2 3 4 5 6 times 3, that is 18. This should be 6 times 4, so it will be 24. So that we have to change the drawing. Anyway, so let us go to the comparative analysis. So lighting load calculation. So let us see and compare between area method and lumen method. So lamp per fixture. In area method, we have one lamp in one fixture. In our lumen method, we have two lamps in the same fixture. So lamp watts. In the area method, we assume 100 watts, but here in the lumen method, we selected 20 watts only, as we desired, as I desired. So fixture watts here is 100 watts, but here in the lamp method, in the lumen method, it is only 40 watts. So big difference. So it will be energy saving. Number of fixtures here, area method, we have 28, but here in the lumen method 24 with less wattage, here 28 with more wattage. Total lighting watts, see 2800 watts, here we have only 960 watts in the lumen method. Illumination level as per IAS, in the area method not determined as per occupancy. So it is not determined, but here in the lumen method, it is determined. It is 200 lux, and it is satisfied. So summary, using the area method, it will be costly because you have to assume, and yet you don't know the illumination level. So also mention no proper illumination. That is correct. Lamp lumen unknown. Of course, it is not given. And only rough estimation. So this is only rough estimation, area method. But in the lumen method, it is low cost. It is very clear. Low cost because you can determine the number, the wattage, and the lux is recommended is met. So energy saving also, obviously you can see. And it is meeting standards and using the standard tables. And of course, this is a detailed calculation.